Okay, try again. Calculating pH from hydroxide ion concentration. So we're supposed to calculate the pH of each solution and indicate if it's acidic or basic. So we need the pH equation. pH equals the negative logarithm, and that's not anti-log or anything funky, that's the logarithm with the sign changed, of the hydronium ion concentration. Okay, so that means negative log of this number, 9.5 times 10 to the minus 9. And find the calculator. And how you enter this into your calculator depends on the style of calculator that you have. Some of them you're going to enter the number and then press log and then press the minus sign. And others you're going to do minus and then log and then 9.5 EE minus 9.
What other calculator that you recommended or get?
The TI-30X Pro, you'll do it just as it's written. The negative sign, not the subtracting sign, but the negative sign, and then the base 10 log. And for that one, you have to press that LN, LOG button twice. The first one will give you natural log, the second gives you log, and then enter the number. And I get a result of 8.02. That's the pH. Any questions? Is that acidic or basic? It's basic. A high pH is basic, a low pH is acidic. So for letter B, it's the same idea. pH is the negative base 10 log of the hydronium ion concentration. So negative log of 6.1 times 10 to the minus 3. Negative log 6.1 EE minus 3. Enter. pH is 2.21. Acidic or basic? It's acidic. Low pH is acidic, high pH is basic. Now, your book talks about strongly acidic and strongly basic and weakly and stuff. What I really care about is, do you know acidic or basic? I'm not going to get you on the weakly or strongly acidic or basic. Any questions? You can do this calculation even if you have no clue about logarithms. Okay? It's just a matter of learning how to use your calculator. What if we have the pH and we want to know the hydronium ion concentration? Well, then we're going to use this equation. And normally I would derive that here. I'm not going to do that because we are so far behind. But here's the equation. The hydronium ion concentration is equal to 10 raised to the power of the negative pH. And so we'll do a couple of examples with that. Calculate the hydronium ion concentration for a solution with a pH of 8.37. So we're going to use this, the hydronium ion concentration equals 10 to the negative pH. So I'm going to take 10 and raise it to the power of the pH with a negative sign. So 10 to the minus 8.37. Then the question is, okay, fine, I wrote that on my paper. How do I tell my calculator to do that? That's where you're going to want to use the 10 to the x button that I've told you not to use before. Don't use 10 to the x button for scientific notation. But here, we're wanting to take 10 and raise it to a funky power. If you try to use scientific notation here, your calculator will probably protest at you using a decimal in the exponent. So on the 36X Pro, I'm going to press the e to the square, 10 to the square button twice, and that'll give me 10 to the. And then I'm going to plug in negative 8 8.37 and press equals. And I'm going to have to put it into scientific notation to be able to see it decently. It'll be 4.3 times 10 to the minus 9. .3 times 10 to the minus, yes.
So, I'm sorry, I'm not sure. So why are we using this, e to the 10 to the twice instead of like e? What is the difference?
Well, let's try it on EE. Let's try 1 EE minus 8.37. Syntax error. Because in scientific notation, the exponent on the 10 is a whole number. And so it won't let you put in 8.37.
Oh,
Okay? There could be some calculators that will. Fine, do it that way.
syntax error, you know,
Yeah, it's like, oh, no, that's not going to work. And so you want to use the 10x. Yes?
So for some calculators, when you do the equation, the 10 to the power, it'll just give a bunch of zeros and then you'll see the 4.
Mm-hmm.
So how could we get them through to show?
That's a good question. Most calculators will allow you to switch between scientific notation display and normal decimal notation display. Okay? And so if you don't know how your calculator does that, come and see me after class and I'll show you how it does that. That is one of the very few things I do not like about the 36X Pro. It will do it, but it's a bit of a pain. The TI-30XA is much easier. You can just toggle back and forth. It's really nice. But the TI-30XA doesn't do a whole bunch of other stuff. So I still like the 36X Pro. Any other questions? So pH scale, we talked about. There's also a pOH scale. pH was the negative log of the hydronium ion concentration. pOH is the negative log of the hydroxide ion concentration. So there's a relationship between pH and pOH because there's a relationship between hydronium and hydroxide ion concentration. And normally I would derive that here, but again, we're short of time and most of you really do not care. So if you care, I'll be happy to do that for you after class. pH plus pOH equals 14 is what it comes out to be. So pOH plus pH, the sum of those is 14. Actually, let me show you the circle of life pH style. Okay, so we've got pH and we've got pOH and we've got hydroxide ion concentration, bless you, and we've got hydronium ion concentration. And you can convert between these, and they basically make a big circle. So circle of life. So converting between pH and pOH, I just wrote that up there. pH plus pOH equals 14. So if you have the pH, you're trying to get pOH. You use this equation. We've looked at the relationship between pH and hydronium ion concentration. If you have hydronium ion concentration, you're going to do pH as the negative log of the hydronium ion concentration. And if you want to find hydronium ion concentration from pH, it's equal to 10 to the minus pH. If you're going back and forth between hydronium and hydroxide ion concentration, we use that KW equation. KW equals 1.0 times 10 to the minus 14, which equals the hydronium ion concentration times the hydroxide ion concentration. The relationship between pOH and hydroxide ion concentration, the same equations as for the pH, but wherever there's H, you put in OH. So POH is the negative log of the hydroxide ion concentration. And the hydroxide ion concentration equals 10 to the negative POH. So those are all the relationships. Any questions? You may have been scribbling that down. Another way you can get a copy of that is to go on YouTube to the video and play it on your smartphone or on your computer, pause it and take a screenshot right here. And then you have a nice copy of it. Okay, so calculating OH minus from POH. So we've got the hydroxide ion concentration and we have the POH. Did I skip one by accident? No, I didn't. We have POH, we want hydroxide ion. So the hydroxide ion concentration equals 10 to the minus POH. So that's going to be 10 to the negative 4.25 power. .6 times 10, let's see, 5.6 times 10 to the minus 5. Would the concentration have units? Yes, the concentration has units. And one of the earlier problems, I forgot to put them in. The units are always molarity. So it's 5.6 times 10 to the minus 5 moles per liter. Any questions? We're going to do a lab next week that will give you a lot of practice in these pH type calculations. It's also really neat because we're going to use red cabbage juice as a pH indicator. And there'll be lots of pretty colors. So it's a fun one.